Good morning, or whenever you're watching this, hello, greetings. As you go through chapter 11, there are just a few skills that you need to have in order to simplify the problems properly. And those skills happen in chapter 10, which clearly we don't have time for any more lessons, but I thought I would just give you a crash course in what you're expected to know as you are working through chapter 11. So there's just two quick skills. And the first one is how to simplify radicals. So a quick review from chapter 4 and factoring and all sorts of other things is that 5 squared is 25, so 5 times 5, think pairs in this case, is 25. So when we reverse it, the square root of 25 brings us back to 5. So when we think of perfect squares, just like we talked about in the factoring chapter, 4 is a perfect square because it's 2 times 2, and 9 is a perfect square because it's 3 times 3. And so my point here being is that we're going to be searching for these pairs when we simplify a radical that's not a perfect square in and of itself. So let me see if I can't get this to be a pencil looking. There we go. All right. So step 1. If I'm trying to simplify something like the square root of 18, step 1, go ahead and do a factor tree on that number. It doesn't matter if you see this as 2 times 9 or 6 times 3. When you get to the end, it's all the same. So let's say somebody sees this as 6 times 3. And then break down the 6 for 2 times 3. And so this right here represents a perfect square. 3 times 3 is 9. So go ahead and just go through and circle any pairs that you might have, and then cross one of the pairs out. And anything you circle breaks outside of the radical. And anything that does not get circled does not have a buddy, per se, to break outside the radical. And so those numbers are stuck inside. So the square root of 18, or radical 18, simplifies to 3 radical 2. And that's really basically it. I have a few more examples here we can look at. Square root of 108 gets a little bit more complicated. Remember, things that end in 8 have 2 as a factor, so we can go 2 and 54. 54 is 9 times 6. 9 breaks down to 3 and 3. 6 breaks down to 2 and 3. And so I have a pair of 3's right here. One guy is going to cancel. I also have this weird pair of 2's here. So imagine I'm kind of circling that all at the same time. And then one guy canceled. And any numbers that are circled come out. And the main operation here is multiply. So we're going to multiply these numbers back together again. So 2 times 3 is 6. And that 3 doesn't have a buddy. And so that 3 is stuck underneath the radical. When we look at 75, 75 is 3 times 25, which breaks down to 5 and 5. Circle your pairs. One guy cancels. The 5 goes out. The 3 remains inside. Now, sometimes, oh, I still have more. All right, let's keep going. At any point, you can pause and try it on your own. All right, 32. This has a lot of powers of 2 in it, so I picked this one just because it gets a little obnoxious. So 2 times 16. And if you recognize the square root of 16 as being 4, you can kind of stop right there. If you see that perfect square and you go, oh, well, the square root of 16 is 4, then that 2 is kind of extra, you can jump straight to that. But not everybody sees it that way. And so 16 is 2 times 8. 8 is 2 times 4. So my way is not the only way, it's just one way. And so circle all your pairs. We have a pair of 2's there. We have a pair of 2's there. This guy cancels, that one cancels. That 2 comes out. This 2 comes out. As you can see from the answer, 2 times 2 represents that 4. This 2 right here is not circled, and so that is represented by what is left underneath the square root. Let's do it one more time. 56 is 8 times 7. 8 is, and there's other ways to do that as well. 8 is 2 times 4. 4 is 2 times 2. And of course, it doesn't really matter which pair of 2's you circle. You're circling a pair. So one guy cancels. This 2 doesn't have a buddy. That 7 doesn't have a buddy. So this 2 comes out. And that 2 and that 2 regroup. These 2, I probably shouldn't circle this because I don't have the button to undo that. But those 2, they're not a pair, so I'm just illustrating. Those 2 get remultiplied and are stuck inside that radical. All right, just a few things as I teach this method. It's possible that sometimes you just have something that doesn't have a pair. So radical 11 doesn't simplify. It's just radical 11. And then I also run into students who get confused when they're looking at something like this because they just get so used to simplifying everything. Don't forget what you know. Your perfect squares, the square root of 36 is 6. Now, if you go and break that down, sure, it's going to work. But look at how much extra work I'm doing. So it's super helpful to know those perfect squares by heart so you can just have that number recognition, and then you cancel, and then you circle here, and you cancel, and that 2 comes out, and that 3 comes out, which is where I get this 6. And then some students get confused, and they're like, gosh, what's left inside the radical? It must be a 0 or something. No, 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 you don't need to do any of that. The square root of 36 is 6. All right, so sometimes there's nothing you can do. Sometimes there's no radical in the answer, and then you have all the variations in between. All right, next piece. Next piece has to do with negative radicals. Sometimes when you do the quadratic formula or complete the square, or even the square root method, which is some of the ways you're going to learn how to solve a radical, in sections 11.1 and I believe 11.2, and occasionally you will end up with a negative underneath the radical. Now, in section 10.8, and maybe in previous math classes you have taken, some going all the way back to high school, you will have learned that we have defined this imaginary number I as being equal to the square root of -1. And then we say, okay, well, if we multiply I times another I, that would give us I squared. And if I square this, multiplying something by itself that is underneath a square root kind of cancels that radical out because they are inverse functions. And so we are left with the idea that I squared is equal to -1. So I itself is equal to radical -1, and I squared is equal to -1. And that might be something you're expected to know when you hit your next math class, but you'll need that little tiny fact to simplify these negative radicals. So what we do here, what you need to know for this class, for this moment in time, is pretty simple. If you have a negative underneath the radical, we call it pulling out the I. So separate the negative part from the positive part. And the square root of -1 is I. And I've seen lots of textbooks put the I in front. of that radical. But the proper way to do it is to write it in the back. And so the way we normally write a complex number is in the form, sometimes there's two pieces, a plus b I, and the I always goes behind the constant. All right, so I goes in the back. So this would be our final answer. If it is a perfect square, you would write that as 3i. And it's interesting, if we teach chapter 10, we talk about how we're only going to consider the positive. When you're looking at chapter 11, you're going to add a plus or a minus in front of those radicals when we go to do quadratic formulas. So in this case, it would be plus or minus 3i, and the I always goes in the back. That's really it. If you simplify something, let's just make it quick. Like, oops. Getting ahead of myself here. If you simplify something like this, and you imagine separating the -1 piece from the 8, you would still just simplify this by pulling out any pairs you see. Circle your pairs, one guy cancels, and so this 2 comes out. Don't forget the plus or minus for the purpose of what you're going to see in chapter 11. All right, so that 2 comes out. This 2 stays underneath the radical, and this part right here becomes the I, and we put it in the back. It is not underneath the radical, so even if you need to have a little gap right there, don't extend your radical like all the way across. Don't do that. Leave it just like I wrote it right here. And that's it. So those are the skills you need that you don't have yet to dive into chapter 11. Good luck, and as always, let me know if you need any assistance. Take care.